Hello, welcome to my presentation. We're going to talk about the second experiment, and this is about the full adder circuit. So I'm going to draw them, and we'll see how to implement them using Xilinx schematics. First, I have drawn XOR gate, that means exclusive OR gate, and then three AND gates, and lastly the OR gates. Since you know about since you have watched the video of the schematic part, so I don't need you to remember the format of the Boolean equations. You already known about the equations, how to solve them and how to implement them. But now you need to operate these ports in order to put them in A, B, C, and C in inputs. So let's get on with it. So first, I'm gonna rename it for A. That means it's A version. I think that's fine. And bring it up a little bit. Okay. And then it should be B. To be honest, it's B now. So now we know these three. This is the sum and this is the carry output. So before designating these two outputs, we're gonna check with the input ports. We need input ports and these in those input wires. So let's connect it with A. So in here we need to have the add a wire. Yeah, this is the add wire. So let's put it like this one. Oops, I didn't think it can work. Select it again. So then I can connect it with this. Then I can connect it with this port because this is going to be another A port. And be like this. And then for the B, I can choose this one and connect it with B here. Now for the C in, you can let's put a input output marker here. And now you can press the escape key and then rename it to C in. So you can have C in. I think that's gonna work. Oh, it's not. So let's put a legal name like put a space. This one is the C in, right? So let's just extend it a little bit. I can extend it like this one. Maybe it'll work, yeah. Now let's get back with the input ports. So for this one, it should be the C in, and this one is C in as well. So we can connect it with B, right? I'm sorry, we can connect it with the first input port in here, right? Let's add wire then. This one, yeah, this one is add wire. And then connect the C in here. Okay, I think that's good. Now, for this gate is done, right? Now we need to worry about, we need to think about this gate. So in this gate, we can assign like what? Like C in and A, right? So you can extend it. Sorry, it should be B and C in. So let's extend it. I have the add wire mode, then have, okay, then I can extend it to the B, right? Okay. Now B is connected. What about this one? This one is C. So you can connect the C with this one. Oops. I think it's just, it's messy, right? Put it like this one. Now it looks good. It's okay now. So we have wired the exclusive OR gate and 3 AND gates. Now we have to move on to the final OR gate here. We need to connect these 3 AND gates, this another OR gate in order to fulfill the Boolean equation which we saw in our first video. So let's add the wire again. This one's for here, and this one is for here. I think we're pretty much done. So now we have to assign the output ports. So let's check, let's click on the input output marker. So it is the automatic marker. And let me see this one. Yeah, it's working now. And this should be the Cout, right? It should work. Now we need to, now I'm pressing the escape key in order to get out from the input output marker. Now I'm gonna rename the output port, this output port, as a sum. Right? For the next one, the output, it's going to be Cout. All right, now it's done. So our schematic is done. So we can check the design. Let's go back to the design part. Yeah, so we can check the simulation part, right? So we have to put it simulation and then select it. Then you have the ISE simulator. And check the simulated behavior model. So let's go into that. Yes, I think it's fine. It's running. It's taking a bit long time. Okay, so the simulation is done. Let's switch the screen for the simulator. Go back to the new one. Okay, so you can see the screen, right? So now we have those wires, and also we have the input and output ports. So in here, let's put the observation period as 100 nanoseconds, and then check it out. 100 nanosecond. And then we have these wire connections. We can delete them, right? So we are going to delete them, and now it's done. Now we have 2 outputs and there are 3 inputs. So we're gonna force clock for each of the input ports. So let's do it. Clock. same as before. Have the trailing edge, and the period should be like what? Let's put it 100 nanosecond. I think it should be fine. Okay, now this one, first clock, 0, 1, and it should be half of the previous one, right? Okay. It will be 59 seconds. Now the third one, it's the same procedure. 0, 1, and it should be 25. Now we have to play the observation period now. So we have the signals right here, but in order to see all of the outputs, we can change it a little bit. Oh, it's gone the other way. So can we check it out a little bit? Okay, so let's change this one to what about 200 nanoseconds, right? It's gonna work. Let's check it out. Yeah, it's I think they'll be fine. Let's again go into the part. So, oh, it's fine. Okay, now you can see the output in here. So as you can see, if we have the 0 in here, the clock's signals are changing a bit, right? So if I drag it here, you can see the outputs are changing. So you can try a different number for the observation period and see what's going on. And here you can check it with other kind of values for now. So just make sure you have the outputs something like this one, so that I can observe the whole period in here. So if I change it a little bit more, then what would happen? I think. Okay, so it's nothing like that one. Okay. It sounds good, right? Now it should be. You have to change the way it's displaying the signals. I think that's fine. So we can check it with the outputs. So in here, if you drag it and check the output of the sum and the carry C out, right? So let's get back with the Vhdl test bench code in order to put the signals manually, and you need to code it up. So let's get back to that part. So I'm gonna close this one. So as we have done with the part, oops, I don't want to save it right now. Nope. So now we have to add a source for the Vhdl implementation. Get back on it. Okay, so new source. Not this one. new source, then Vhdl Testbench, name, okay. I'm gonna give it a name. It's all right. Yeah, it's associated with the schematic we have. It's running the Vhdl code. So as you can see, those library functions, class, and port names are already being imported from the schematic. And remember, you need to force the clock in the your timing diagram in order to have these signals, in order to have these ports. Otherwise, you need to code all of them manually, so which will be very tedious, right? So let's go over to that instantiation part. If I'm going to have the signals, then as you can see, these three inputs are the one we have to instantiate. That means these are 3 ports, and they're the standard logic. Let's put 0 in here. As we know, the type is string, data type is string, so you need to put the string. You need to put it in string format. So then it's kind of same as before. It's just the same procedure you need to follow. It's very easy. So I'm gonna put that here in here as well, since this is the carrier, right? You don't need to instantiate your sum and ci because they are the output ports. Now begin with the unit under test. And here you have the port map, which is already been assigned. Then you have the test bench. The test bench you need to begin, right? How do you do that? You have 3 inputs, so you need to have 3 clock signal. 3 clock instantiation, right? So in that case, we can have the process. For example, for instance, I can name it TBA, test bench for clock signal A, right? And begin the process, wait for 100 nanoseconds. Oh, sorry, yeah, 100 nanoseconds. Wait for, I've begun the process. Now I have to wait for 100 nanoseconds here. So it should be 100 nanoseconds, just the same as before. Now, also you need to put a clock, right? You have to put a clock like this. And that's the one. Begin with copy and paste it for clock B. So it should be for B, so TBB, and this one is A. Oh, sorry, I forgot to put not, otherwise it won't get the clock signal. So this one should be B, and same thing is it will go on for the carry, right? So this one is TBC in, so we're gonna write C in, not C in. Oh, this one should be 50 nanoseconds for B, yeah, for B, and this one should be 25. We have 25. Same thing has been done in here. In the first, the same part of our first lab, we declared this kind of clock signal. So it's not that difficult, so you can, copy and paste something like that. Now we have finished our Vhdl code right now, so we need to the simulation again and check it out. You can check the syntax if there is anything, anything wrong, or any kind of error. So yes, and there are lots of error with that. Let's check it out first. I think something wrong with the signals are there, but it has gone wrong. Okay, let's see with this one. It should be 100 seconds. So I think I have this mistake. Let's check it out again. Okay, there's an error. So I got the problem. I think this one is missing the 4. You have to wait for 109 seconds. So I think that's the mistake I've been making so far. Let's check it out again. Okay. Check the syntax again. So now it's okay. So now we can ignore the warning for Verilog file because it's on Vhdl. It's okay. Now let's simulate the behavioral model. That part is okay, I guess. So let's switch the screen. So now all of them are in here. So we can have 100 and no, okay, so it's good. You can see all the outputs in here. So in the 100 nanosecond, it's having you have 1, if you have A as 1, B as 0, and C in as 1, then the sum should be 0, right? And the carry would be 1. In that case, we have got sum as 0 and carry as 1. Likewise, for another one, let's pick this one. If you see the A, B, and C input values, 1, 0, and 1, which means you're gonna have sum 0 and 1 again, right? So in here, this is the same. Let's pick another one in here. You can see the A, B, and C. A, B are both 0, but C in is 1. That's why I've got sum as 1 and carry as 0. So you can check it out to see if it's working. And using the Vhdl code, you can check the timing diagram as well. But remember, you have to draw the schematic and then run the force clock in the timing diagram, and then come back to the Vhdl test bench to see if it's working. Remember, for the codes, you need to check the syntax because I've just missed the 4 keyword in the process of clock signal. So, and also some other, I think I didn't put the space. So remember, you have to be careful with those mistakes because sometimes it could happen in the test bench code. So thanks for watching the video. Take care.